I'm Carl Mathias. I work on the site engineering team as a lead SRE at New Relic.
And my name's Sean Kane. I'm also a lead site reliability engineer at New Relic.
And we just kind of wanted to give you guys an overview of the last year and a half of production for us with Docker at New Relic. And we're going to talk a little bit about kind of the first platform that we built. And yeah, that was a little brief message from our legal department there. Everybody caught that, right? Okay. So we, yeah, after the legal stuff, what we want to talk to you about is actually kind of why we put Docker in production, sort of the platform that we initially built to get us there, some of the lessons that we learned and some of the best practices that have come out of that from the last year and a half in production, and then kind of the V2 platform that we're working on now.
Right. So one might ask, why did we decide to use Docker, especially a year and a half ago? I mean, at this time, this was like October of 2013, right? So Docker was like version 0.6. It had actually only been publicly released basically in April of the same year. But we had a few things going on in the company that were actually made it sort of an ideal time to potentially look at a new technology and something that was going to enable us to move faster, grow, scale. One of them was that we were taking basically 5 products internally that sort of made one large product, the APM product that New Relic has. And we wanted to break that up into services, basically migrate to an SOA type architecture. We also had a new, basically our first additional product that we've ever launched in New Relic, which was New Relic Insights. This was our business analytics product. And so we sort of had some greener fields anyway. We had a product that actually hadn't launched, although it was built out in our staging environment. So we had some opportunity to try to change some of the ways they were doing things. And it was also going to basically overnight double our server count. So some of the things that had gotten, we'd gotten away with early on, some more manual processes simply weren't going to work. And there was incentive to try to figure out a better way to do it. And one of the initial things we wanted to fix was our deployment story. As we got all these services, we wanted to get a more consistent way that application teams, as we started to operationalize these teams, and then we expected them to own their code all the way into production, we needed a good deployment story where they were actually all doing things consistently. Because as it was, we had these per team Capistrano and sort of rake-based tasks. And each team did it slightly differently, and some of them didn't. An old engineer had written the code who had long left the team, and there wasn't even familiarity with the teams on how their deployments worked, and we were trying to fix that. We had incentive to make that better.
And one of the riskiest things you can do with an application is actually ship a new version into production, right? And this is a thing that we were doing, 5 times a day. Most of our apps deploy every day. And with this breakout of this SOA, we were going to go from like 5 to 30 deployments a day, we expected by the end of 2014. And we were trying to figure out how to make that less risky. And by giving everybody the same set of tools and the same environment, we could reduce that a lot. So Docker looked like it was going to be a good start. And so we're going to tell you about this platform we built. And actually, it scaled quite a bit beyond what we expected. We thought we'd be revisiting it by the end of 2014. As it turns out, we're actually just revisiting it now. We're going to tell you the details here, but just so you understand, like, kind of where we are. We have 75 or more projects that are actually deploying on this. We've got 15 production development teams, at least. I think there's more than that now, that are shipping their stuff in Docker in production. And then we put 250 on the slide, but I think we now have 300 or more production containers that are actually running, and those are concurrently running. We turn those over multiple times a day. So the last numbers we saw, I think, were like 700-ish container starts a day. And that's mostly the middle tier of our services at New Relic. And so it's worked well for us.
Right. So now we're going to talk about the platform that we are currently running on, and the one that we built over the last year and a half and that has gotten us to where we're at today. one of the things we wanted to do early on is take a real simple approach. And so as I mentioned earlier, solving the deployment story first, this was our biggest thing. Like, how can we get applications into production in a very, very consistent way? And one of the things we learned, like the most important piece of advice, I think, if you walk out of here, is that simple solutions actually work. Like, we really tried to avoid sort of doing this big design up front where we're looking at, oh, how do we build this really elaborate Docker, like basically platform as a service, and how do we solve all the hard problems right up front? Instead, what we actually did is we looked at a real problem that we had today, something that was manageable, so in this case, the deployment story, and we solved for that problem first. And then we iterated on that and actually grew the platform. So we built a minimal viable product, basically, of a Docker platform to start with, and evolved that product as the year went on.
So we wanted to use some of the things that we already had in place that worked pretty well, and we didn't want to go and try to build a whole platform as a service right up front. We wanted to prove that the Docker story was going to work for the company. We wanted to prove that there was business value here. So we'd been running applications behind F5 load balancers for a long time, and we thought, this is a pretty simple form of service discovery. I give you a URL to a load balancer. It knows where to find my stuff, and that works. We talked a lot about doing some dynamic stuff, and at first we said, we can rely on the health checks from the load balancers to tell us which servers actually have the containers running and healthy. So if we just configure, with our initial pool, all the services, then it will work. In order to make that happen, we assigned dedicated ports to every one of our services. So there's, you can always rely that on this port on any of those hosts, it'll be the same service, which means I can point the load balancer there. And even if there's not a container there, the health checking will fail. And as soon as there is a container there, we'll discover it, it will show up, and suddenly it'll be added to the pool, and everyone can reach it.
So process management was something that we looked at very early on as well. This is a little controversial in the Docker community and in containers in general, is this argument about whether you should only run a single process within a container. This is mostly a preference thing. The idea behind only running a single process is for simplicity and to sort of force people out of that idea of I'm going to have like a bunch of processes and I'm going to tie them all together. The idea of containers is to sort of pull those things apart. But for resilience purposes early on, and because we were really new to containers, we wanted at least something that would actually watch the process within the container and make sure. So most of our containers have two processes. They basically, we are using supervisor D, and supervisor D is actually the thing that runs the service within it. This gave us some benefits because it allowed a lot of situations where, like with C groups and resource management, which we'll talk about a little later, where it would come in potentially and actually like we would have a memory leak or something in a service. The service grew beyond the memory bounds it was allowed to have. And the kernel would come around with the out-of-memory killer and actually kill the underlying process that was using all the memory. The nice thing was because we were using supervisor D, that process would die, but supervisor D would actually restart it without the container itself needing to be restarted. Early on, Docker was not great at this, and actually really early on, Docker didn't even have a story for restarting containers that died. You would have had to have redeployed them. So this actually gave us the containers a little more resilience to stay up and running without us needing to worry about always redeploying them if there was a failure mode.
And since we were treating this as a deployment story, there wasn't anything on an ongoing basis other than Docker watching the containers. So having supervisor D running in the container turned out to be a big win for our load balancing story, which was going to rely on having them stay where we put them. So the next piece was remote logging. Docker supports native logging. It has this kind of JSON log format that it writes to disk, and you can use the Docker command to go and get them. And that's great, except for if your application's actually running across 20 or 30 servers on, in different containers, that's not a centralized story. It doesn't work that great. There's a lot of different things you can do to plug these together. The community stepped in here and produced a lot of kind of external tooling and other stuff. Because we're already running supervisor D inside of each of our containers, what we did was we just wrote a plugin to supervisor D that if the application spits stuff to standard out, supervisor D collects it and ships it to our centralized logging stores. And those are running Mozilla Heka. This is like a really nice log kind of processing system. It's a bit like Logstash, but it has kind of pluggable parsers that you can put into it to generate structured data from your logs. And then in some cases, we are also relaying them out to syslogs for things like permanent storage and for audit logging. And we found out really early on we didn't have this logging story in place. We were just relying on the Docker logs. And that was a little bit problematic. And once we got the logging story in place, it was a big win. If you're familiar with Docker, you might know that Docker 1.6 shipped with centralized syslogging built into the Docker daemon. We're not actually using that, and we're going to continue to wait because the current implementation is a blocking call. And in order to prevent it blocking the Docker daemon, it will actually buffer your logs into RAM. So don't recommend you use that yet. I think 1.7, they're fixing that. But for now, we use SupervisorD, and it's been great. And actually, the plugin that we wrote is on the New Relic. We don't have the link up here, but it's on the New Relic GitHub account if you want to take a look at it.
So the next thing that we had to deal with was both stats about how the containers are behaving at any given moment, and then monitoring in the containers. We had Nagios in our environment already, so we used Nagios initially for some of our monitoring. And then it worked okay, but there were some problems here. I mean, one of the things is we discovered pretty quickly that really in this type of world that Docker is leading us towards, where services, where they're actually running is very ephemeral, they'll potentially move broadly across your cluster. You don't really want to monitor individual containers, right? That we don't actually care if an individual container is up and running. What we care about is the health of the whole cluster. And so one of the things that we're working on right now is actually to instill this idea within our development teams of creating a service that actually understands, a monitoring service that understands their cluster, that understands when it's healthy, what in is, what in plus 2 is, and then can actually report. So we can set up Nagios basically to talk to it, and it can actually tell Nagios, hey, the service is healthy or the service is not healthy. And we only wake up engineers in the middle of the night, not because a single container has failed, but because 3 containers have failed and the service is about to fall on its face unless somebody actually gets up and works on it. And one of the ways, some of the things we did to do this was like we actually instilled, during this whole process, a lot of standards. We tried to embed standards everywhere we could when it made sense, but really small, simple ones. So this was like this status check endpoint. We said every single service that runs in our environment should expose a simple HTTP endpoint, a /status/check, and it should respond to 200 OK if the thing is healthy. And it can respond to 500, some 500 code if things are unhealthy. And that means that whatever we do use to check it, Nagios or other tooling, you can have a very, very simple check that really knows nothing about the service. It doesn't have to have any extended logic. And that was a huge win. We also started using a Google cAdvisor. This is actually, can be run locally on a Docker host. We deploy it as a container. And cAdvisor gives us a lot of the statistics about how the containers are running on the system, each one, how much memory and CPU it's using. It has both a human readable interface, which is great when you're an ops engineer and you're just like, why is this one host behaving strangely? I need to look at it. But it's also got a JSON endpoint that can actually stream stats data to something so you can ingest it into your analytics tool or whatever you happen to be using. Let's see. Oh, and then so the other thing is we've just, New Relic has actually just released a new version of our server monitor that actually has our first true support of Docker containers.
Yeah, it's so it's first class. The idea here is what Sean was talking about. Like, you really want to know, is your application healthy? Not really, are your containers up? This is just one screenshot here, I guess, showing some of the images that are deployed on some of the Docker hosts. But generally what we've done is taken containers and made them first class in the New Relic interface. So you can see your application is on this server, it's in these 4 containers. You can see the individual performance of the container and drill down into it like you can with Linux Server Monitor, which allows you to see kind of the CPU and memory use. And that's been pretty nice for us in tuning both our resource constraints, which we'll talk about in a few minutes, and in monitoring application health. Soon, this will actually be really most of the platform that we're using, we're leveraging the experience that we've had with containers internally to build that out. So that should be pretty cool if you keep watching that space. And then we talked a little bit about this status check, and this is part of this kind of bigger goal that we had of application standards. So the shipping container interface assumes that I can pick up my Docker container and I can move it around and it's going to be the same, and I can write some tools that will work with it, just like there's a single set of cranes and things that work with shipping containers. But that breaks down a little bit, because with Docker, you actually do need to talk to the application a little bit. During deployment, you want to know if it's healthy. So this status check endpoint allowed us to have a single set of deployment tools that would work for all of our applications. We could say, is it healthy? The container I just spun up, and I always know where to look. The second part of that was Docker supports environment variables as first-class configuration store, and so we required all of our applications to take their configuration that way. That has a bunch of benefits. It means that we can actually build a Docker container and take that same image, and we can run it through unit tests, we can run it through integration tests, we can put it in the staging environment, and we can put it in the production environment, all from the same build with the same dependencies in the container, and we know that it's going to work. And the only way that we can do that is by passing the configuration into the container in each of those environments. So rather than having the configuration information stored in files that are in the container so that you'd have to rebuild it for each one, that's been a really big win doing that. The second piece of that is, if we're going to treat them all the same, and we run a lot of the same kinds of applications, our network, we have really kind of a set of Ruby production apps and a set of Java production apps. So what we did was build out standard base images for those. So we said, application teams, you don't need to suddenly become experts in all of the Linux configuration stuff to make your app work. We're going to give you some base images that do most of the right things. You have the power with the Docker file to go and add stuff and change stuff if you need to or want to. But for the most part, the thing we give you is going to just work. And that's turned out to be really useful as well, because it means that if there's a patch in a library that needs to be upgraded, we don't have to rely on all of our development teams to get that right. We can just put that in the base image. When they do their next build, they'll pull down the newest base image, and the next build will ship with the patched version of the software. But also, it will go through test and staging with that same patch, which is a really useful mechanism.
So as we started to get closer and closer to actually deploying containers, we discussed, well, how do we build containers? Right? How do we build the images first that our developers, do we want them to have to understand everything about Docker, how to build a Docker file? And the decision was, no, we don't really want to do that. We actually wrote a small tool called Shipwrite. It's pretty easy, but what it would allow somebody to do is if they had a Git repo that was, let's say, a Rails application. And we sort of knew, okay, for Rails applications, this is how our dev teams do this. Then Shipwrite could take that code base, create a standardized Docker file for it, build the image, and then actually deploy the image out to our registry and make that available. So this allowed us to embed basically, our own internal best practices about how we thought a Rails app should be built into a Docker, or how a Java service should be built into a Docker image, and build that into the tooling. And again, still let our developers really focus on writing the service that they needed to write, and not understanding the deep intricacies of the way Docker worked. Now, on the flip side, it was flexible enough that if they wanted to, it could push out a template Docker file. They could check that in, and if they had a unique case and they wanted to do it, they still had a way to do it themselves. But this gave them guidelines to lessen the friction of getting into sort of this Docker world.
And the result of running a Shipwrite build is that you actually have your image built and shipped to the registry. So it's actually sitting in the centralized Docker registry, which means that deployment tooling can come along and pick it up and drop it from there, so that the developers don't even have to script that piece of it, which was good. We also, early on, did not implement any kind of controls on resource management. We didn't have a lot of applications, so we sort of gave them their own servers and let them go. And as you might expect, if you've run lots of applications on the same servers, that doesn't work very well. We didn't expect it to work very well for very long, and it didn't. Docker supports first-class resource constraints via the Linux C groups. This means I can control how much memory is allocated to each application. It means I can control how much CPU they get. And that turns out to be really powerful because it allows me to pack a lot more applications on the same server without the noisy neighbor problem. I don't have this service when it goes crazy and somehow is using a new version of the library that has a memory leak. It doesn't take out everything else in the box. And because we're running supervisor D inside the container, usually the worst thing that happens is that the out-of-memory killer will kill it, or the CPU constraints will just cause it to sit there and burn up the little bit of the CPU that's allocated to that application. The other thing was, because we weren't doing resource constraints at first, we were spinning up lots of AWS instances with containers for each application on separate hosts. And then we did a little better than that. We went back and kind of combined them into hosts and had things that were nice to each other running on the same box. But as Docker's support for C groups got better, not only were implementing the resource constraints was that better for the applications, but what it meant was we could pack a lot more stuff onto the same host. So we just pooled everything into a single big cluster and used the resource constraints to keep everybody from stamping on each other's toes. And additionally, because we're now in one big cluster, all of those resources that we had kind of spread out for all those teams were pooled in one place, which meant we had a lot more spare capacity, and we could spike larger numbers of containers for each service.
So another thing we had to deal with is, how do services find each other? We talked a bit about this with the load balancing earlier. But one of our decisions to avoid the issue of, how do we know what's running on which port? And some of those questions was to create an internal port registry. So every service had this dedicated port, and that could be used. Individual services could use that to look up where a particular service, what port it existed on. It also, one of the things we learned around this port registry is we took this about halfway to where we probably should have done it. So our VIPs that were on our load balancers, because historically, right, HTTP used port 80, used port 443, all our VIPs on our load balancers actually use those ports, which meant although we could connect to a Docker host and we could see, hey, something's running on 8123, what is that? And we could go look it up and say, oh, okay, that's that service. We couldn't actually do that on our front-end load balancers, because then we just made everything port 80. We had to which meant every service had to have an IP address, and then that was port 80. We'd use port 80 on that. Because that required us to gobble up tons and tons of IP addresses on our load balancers, and it removed this visibility that we actually valued. If we were to redo that today, we would actually expose those ports all the way through. So even on our VIPs on our load balancer, you would just go to that IP address, the same port, 8123, and you would talk to that service, which also means that we could use one IP address potentially on our load balancers with a bunch of different services bound to different ports on it.
And it means that anywhere that I am running TCP dump on my network while I'm debugging and I see traffic to that port, I know exactly what service it is, which is really useful. So the core piece of our platform, we've talked a lot about the Docker stuff and the application stuff. The core piece of the first platform that we built is a tool called Centurion. This is a multi-host deployment tool. Paul Showalter and I spoke at DockerCon last year, and we open sourced it there. That's the URL to it. This allows you to orchestrate the same configuration with the same port bindings and the same volume mounts across all of your hosts for the same application, and it supports multiple environments and all the things that we use to do deployments with. And we've been running it and iterating on it in production for, I guess, basically a full year and a half now. We've had a bunch of open source contributions from other people around the world, so you should check it out. But the cool thing that this allowed us to do was, remember, we're still treating it as a deployment story, so it's a tool that runs while you do your deployment and it's done. But it allowed us to do rolling deployments for all of our applications without the application developers having to do much. So we had that status check endpoint that we talked about. Centurion would just leverage that. You can actually set it to use any endpoint, but in our environment, it's always the same. So leverage that to make sure that it could go to a host, bring down one of the existing containers, start up a new one, health check it until it's alive, set up the timings appropriately to work with the load balancers and move across your pool. Some other major advantages were it allowed us to put all the configuration outside the application like we described. They're all in a configuration file that sits inside a single repository at New Relic. You can actually put them in different repositories. But by putting them in a single repository, we got a couple other advantages. One was our security team was really happy that we didn't have these things like database passwords and application secrets stored in many repos all over the application stack. The other thing that it allowed is because all that stuff's in one place, if you're on call and you're working on an issue and you need to deploy it, and maybe you're not the specialist for your team on the deployment side, or maybe you're an ops engineer and you're trying to help debug something, you know exactly what to do to deploy any application in the environment. So because they all behave the same and the configuration's all in the same place, I can go pick up an application that I've never seen before, and I know exactly what to do to deploy it, and it works. And that's been a huge win.
So now we're going to talk a bit about the new platform we're building. So after a year and a half, we scaled up this simple platform, and we've done really well by the platform that we built. It's helped the company get from basically 0 to where it is today. In that time, we've grown from a single product to a multi-product company. New Relic went public in that time and saw huge growth. And the platform worked. It wasn't perfect. There were definitely rough edges, bumpy road during the process, but it got us to where we were at. And now we've learned a lot, and so we're actually building sort of our V2 platform today. And one of the first things that after looking at all the options that are out there that we decided was that we liked both the paradigm that it was presenting and what it would allow us to do was the Apache Mesos project. And this is basically a tool that can sort of take all your servers and instead of even, we've gone from that time where, our servers were our pets to the point when, when we cared for each one individually to where they're cattle and we like to think, okay, well, we don't really care about servers. If one dies, no big deal. Now we're actually going to, I don't even necessarily want to think that there's a server there. What do I really care about? What I really care about is that there's CPU, there's memory, and there's disk out there. And there's some amount of it, and maybe there's some things I care about, like how fast that CPU is, how many cores are available and free that I potentially could use. And Mesos is basically something that looks at your servers this way and can present resource offers to some of these frameworks, which he's about to talk about. When you say, hey, I need a task and I need this resource for it, Mesos is the thing that can make those resource offers.
So the second part of that is running on top of Mesos, you need a framework that acts as a scheduler, determines where things, which of those resource offers you're going to accept. You say, I have an application that needs 6 instances, and I need 2 gigs of RAM for each, and I need 4 cores. And something's got to handle that. So we've actually picked Marathon, which is a project from Mesosphere, and it's called Marathon because it's for long-running jobs. Yeah. So, but when you invoke a task with Marathon, it actually sends a call to Mesos. And then on our side, you can let Mesos has first-class support for Docker. It can actually run Docker containers. But we have a few things we want to do custom in our environment. So the nice thing is all the pieces of Mesos are pluggable. So we've actually written a custom executor that runs on each of those hosts. And when the task gets sent to Mesos, it actually calls our custom executor, which knows how to use our Dogistry tool, which I'm going to explain in a second, to pull down images to the Docker host. And it runs them. And it actually sits there for the lifespan. It's a really tiny little application that watches the Docker container and reports to Mesos how it's doing. You don't need that, but it's going to work for us pretty well. So the other piece is we've open sourced, we've worked on an open source project that was started by somebody else, but which we've kind of adopted, called Dogistry. And this is what we use now as our primary image store rather than Docker Hub or Key.io, which we also do use. But the main thing that's been great for us about Dogistry is that it allows us to store all of our image layers on S3. We're much closer to S3 on the network than we are to Docker Hub. It's much faster for us, and we haven't had any reliability problems with it, which has been great. Which previously we would have hung deploys sometimes from Docker Hub or key.io because it would stop responding partway through. I think it's a lot better now, but Dogestry's been really big for us. You can check that out if you're interested.
So one of the tools that we're actually building in this platform is called Sidecar. It was inspired, at least partially, by Airbnb's Smart Stack, which is a great tool. It's well worth looking at, but there were some things about it that didn't quite meet our needs. We didn't want to rely heavily on Zookeeper, which was a major component of Smart Stack. And so we basically are designing something that can do service discovery, right? We need to know where our containers are at all times. Distributed load balancing, we're gonna do a demo of this in a sec, but basically the idea is that every single one of your Docker hosts has a local HA proxy, and your services, instead of going out and actually talking to the network, talking out to some external load balancer, instead, when they know that like, hey, I need the service that's on port 2132, they actually can talk down to a special IP address that exists on the Docker host within a network namespace, and just hit that port on there, and the HA proxy is actually listening there and will reroute that. And this Sidecar tool is actually auto-configuring that as containers come up and down. We're using a gossip protocol to actually communicate, so all of these Docker hosts each talk to each other and say, hey, I've got this new container, or hey, this container went away, or it's unhealthy. So that's another thing it does. It does health checking, so it will actually check each individual container to make sure it's properly responding. And you can send, when you deploy your container, you can actually tell it what sort of health check you need done on it, what the endpoint is, and something like that. And then it's actually something we're hoping to have open source later in the year. It's not quite ready yet. We're still actively working on it, but we do plan on releasing this tool hopefully in the fall.
So I'm going to do a quick demo here. I realize we're starting to run short on time. So let's see if I can get this to work. Okay, so what I've actually got here is on the left, I've got a window with Centurion ready to go. I'm going to actually deploy a really fancy web application. It's Nginx with static HTML. But we're going to let it stand in for our production application. It's called Velocity. I'm going to deploy it into the staging environment. And I'm going to tell it to do a rolling deploy. In this case, you might be noticing that I have given it the no pull option. That's because we're on the conference network, and I don't want to wait for it to try to check on images and see if it's happy. But in production, you would definitely want to run the pull. And then on this side, I've actually got the UI for Sidecar running. Sidecar supports a JSON endpoint as well. There's not actually anything in there right now because we don't have anything to show. But right now we've got a cluster here. There's two Docker hosts that are running in VMs on my laptop. And then the thing on the far right is actually my laptop itself. So it's not going to run any Docker containers. It's just participating in the cluster. This is cool because it can actually run a little HA proxy locally and have it configured by Sidecar just like it would. And that's pretty useful. Now, Sean kind of described this. You might see that it's actually running on Docker 2 there. It's also running on Docker 1. And here it is actually on my Mac. So that's the one we're going to watch. And there's just it's a little Go binary that's running on each of these. It's using like 12 megs of RAM. And while I run this deployment, let's watch the Sidecar window. And then I'll go back and show you the Centurion stuff in a minute, because the more interesting stuff actually is going to happen on the right here. So it's starting up a container. You can see it comes up. It's unhealthy. We're waiting for Sidecar to health check it. Now it's come up healthy. It's alive. There's two of these, so Centurion's moving on to the second one. That actually health checked quite quickly, so we see it as alive right away. And then the deployment's done. So if we go and look at the stats port for HA proxy, so the HA proxy on my Mac's actually got this exposed, so I can show you this. what I've got here is actually a front end for velocity on port 10234. And then there's a back end assigned to it. And you can see I've got two things sitting in here on my back end. And those actually happen to be the container IDs, which you can see here. Sidecar actually maps those in as the host names that show up in HA proxy so that I can see them. And then I really want to see if my application's working right. So I'm going to go to Docker 2 10234. There's my great application. You can see that's on Docker 1. I can see that it's actually running on Docker 2. But that's not good enough, right? Because we want to use the HA proxy. We want to go through the load balancer and actually see this thing. I don't want to have to know about which endpoints are running. So Sean talked about that IP address we have it bound to. We've actually mapped that to a name in our environment, so it's just called services. So any host, any service I want to talk to, all I need is the port, and I can just call services, that port, and I'll get it. So now we're going to go through the load balancer, and there you go, success. I can actually do that. I can reload that a few times. And then we can go back here, and we can reload the stats page, and we can see it's actually HA proxy seeing me go through there, and the traffic's working. So this data store is all in memory that we're running for Sidecar, and it gossips around the changes. In order to make sure that if a container just goes away, I know it actually died and just disappear, it supports tombstone records like other eventually consistent data stores. So just to show you how that works really quickly, I'm going to run another deployment. And then I'll talk you through exactly what's going on the left. So you can see now I've got a tombstone record that's appeared. I've got 2 tombstone records now. I've got one service up, and the other one's in the process of coming up. Now I've got both of those up. And with time, the interface sorts the old ones up to the top. So now I can look at my JSON, and I can see there's all of the stuff if I have some other tools that need to use it that are all available. So that's what's going on that side. On this side, there's a whole lot of output here. I'm not going to talk you through all of it. But basically what we did was went and checked to make sure that we had exactly the same image on all those servers so that I don't deploy something with the same name and have it be one image version on one server and one image version on another, because Docker container tags or image tags can move. So it checks that first. Then it goes and talks to each host in turn. Here, it's going to stop the existing container. It's going to create a new one. It's going to check it out to make sure that it got created the way it expected. And then it's going to wait for it to come up. By health checking it, it comes up, it's up, and we see it alive. Does the same thing through the other deployment. And basically, the very last thing we do is go and clean up after ourselves at the end. Let's get this back to... Hold on one second. We'll take questions in a second.
Yeah, almost there, just like. So in conclusion, basically, I mean, the thing we want you to leave here knowing is that the simple approach worked. Docker is definitely a new technology. Containers, most people are very new to containers. But don't feel like you have to jump into the deep end. You can take this one step at a time. It's very easy to do. And one of the advantages of doing this is it provided us, as a company, time to learn, as an organization, about what we needed from containers, the pieces of it that would actually bring benefit to the business and the things that we actually didn't need to worry about or we didn't need to overcomplicate. It allowed us to iterate much faster and much more often. Our teams' deployments became so easy for our teams that there was just no resistance there anymore to getting applications out into production. And it provided us the time to build something better and the thing that we actually needed to allow our business to scale and be successful in the future. So
Sean and I are actually the authors of Docker Up and Running from O'Reilly, which just came out in early release yesterday. It's early release, but it's actually the full book. The things that are still being edited are the table of contents and the index. So check it out if you're interested. And there we are on Twitter. Thanks, everyone.
Great.